Welcome back, student. So centrifugation technique is a centrifuge the solid or light particles from the heavier particles. When you put the substance into the centrifugation machines, and that particular centrifugation machine will be centrifuge, means it will be rotate in near about 7,000 or say 8,000 rpm, and that time the heavier particles will settle down in bottom part, and the lighter particles will be stay in the topmost part, and you can easily separate out the two things. Okay, especially in higher classes you will learn these things, that a colloidal solution exists. There is the one kind of that is your substance, the colloidal state, and that particular colloidal substance you can not colloidal state, it is a colloidal substance. So colloidal substance also can be separated out by the centrifugation technique, like your milk, like your blood. So in pathological laboratory also, blood and other biological samples are often separated by the centrifugation technique, and the process of centrifugation is widely used to separate the cream from the milk. So you know that milk is consist of water and as well as some fat and other things. So water part is maximum, and the cream or oil part is a very less amount. So that time the heavier particles, that is water, is much more denser, so that will be staying lower part, and the lighter part, that is your oil particles, will be stay in the above part when you poured into the milk into the centrifugation machines. As well as your blood is also act as a colloidal solutions, and that time you can also easily separate out the blood and other things, okay, by this centrifugation techniques. So that is the number 10, that is your magnetic separations. From the name you will know that know so what is actually magnetic. So magnetic substance, this method is used to separate the magnetic substances like your iron, cobalt and nickel from the mixtures. Suppose that I will give some experiment. Suppose I have a one petri dish, and I having some irons and some and other things, that is your sulfur. You have sulfur and iron, or you can take the iron and non-magnetic substance like your sand particles. Okay, so now what you will do, suppose that you have to mix it. Okay, suppose you have mixed it, and what you will do, you have used one magnet over it, and the magnetic substances, what are the act as a magnetic substance, that will be attracted by the magnet. That means iron will be attracted by the magnet easily, but the sand particles or the sulfur particles will not attracted by the magnet. So that time the whole iron particles will attracted by the magnet, so iron will be removed from that mixtures, and the sulfur and other, or you can say that the sand particles, that will be also removed from that particular mixtures. So whenever this magnet will be used in separation technique, that will be your magnetic separations. Okay, now coming to the point, that is to separate the constituent of a mixture of a sand, sawdust and common salt. Some other technique is also there, like your sawdust. So transfer the mixture of beaker or half filled water, and stir the mixture as well. Allow the mixture to stand for 10 minutes. The sawdust will be lighter, will float over the surface of the water, and the salt dissolve into water to form a common salt solution, and after that you will be separate out easily. Suppose that you have a sawdust, and suppose that you have a leave it, suppose that you have a some papers in you have a paper pieces, and suppose that you have a sodium chloride, and how to separate out. And that time one process, that is winnowing method, you can easily use. But if you have just sawdust, and that particular sawdust is very light in nature, and the sawdust and the as well as your sodium chloride, when mixed into the water, so that means lighter particle will flow on above the surface of the water. So sawdust will float on the above the surface of the water, and the sodium chloride, that will be mixed into it, and after that the sawdust will be removed by the filtration technique, and the sodium chloride and water, by that process you can easily evaporation, and you can say that the distillation process, very easily separate out the two components. So this is the process. And like your common salt and salt, so in case of sand, so you can easily separate out. In case of sand, you can easily separate out by the filtration technique. Okay, and the sand particles will be left on the filter paper as a residue, and your clear part, that is your superintendent liquid, will come through the filtrations, and that filtration, after the process of filtration, you get the clear liquid, that is actually is your filtrate or supernatant liquids. Okay, so this is the process of separating the common salt, sand and sawdust. Okay, now coming to the part, that is your to separate the constituent of a mixture of iron filling, sulfur and common salt. Suppose that we have a mixture that is consist of iron filling, sulfur and common salt. See, iron fillings and sulfur and common salt, if you have a mixture, that time suppose that you have in a container you mixed iron fillings, sulfur and common salt. And how to separate out? See, in solid state you can easily separate the iron fillings by the magnet, but you have a mixed it. Suppose that in your book it is a mixture in a liquid. Suppose that iron filling and sulfur and common salt you mixed into water. There is one other process. And suppose that iron filling, sulfur and common salt in a solid state, you are not mixed in water, and that time you are using a simple magnet over it, and the iron will be attracted by the magnet easily, and sulfur will stay there and common salt will be stay there. And after that the sulfur and common salt, whole the things, sulfur and common salt whole things will be transferred in a water, and after that the common salt will be mixed into the particular water very easily, because it will make the homogeneous solution. You have learned these things. So, and sulfur particles and the sulfur particle will not mix into the water, and after that the whole solution will pass to a filter paper, and the sulfur particle as usual will be left in the residue left into the filter paper as a residue, and the clear supernatant liquid comes in another beaker by through the filter paper. And after that the sulfur and iron fillings can be easily separate out, and remaining thing, that is your common salt and water, and that means your salt solution. So there is the several technique to separate out the salt solution. Suppose your evaporation technique is available, your distillation process is available. So any one process you can apply it, and you can easily separate out the common salt and as well as the salt solution, salt. In case of evaporation, you will simply heat it, or you can left it in a open surface, and that time the whole water will be removed and you will get the common salt. But if you want to get the whole water as well as the salt particles, that time you use the simple distillation method, and by this simple distillation method you can easily separate out the salt as well as the water. Okay, so this is all about your unit, that is your chapter, that is separation chapter, or you can say the separation technique, or separate out the some component in a particular mixtures. So your work is you just go through this chapter or this unit, and you learn whatever the things you have learned to this from this video, and after that you have to justify it on your in own way, and as well as you have to correlate the other thing. If you have any kind of knowledge with you, and you just apply it and check it, this process is apply or not. Okay, thank you.